Hey there guys, Paul here from theengineeringmindset.com. In this video we are going to be looking at a typical modern heating system in a commercial building. Now there are many variations of how this can be configured and I'll make some videos to show you a few of these variations, but this version is fairly typical of the newer construction commercial buildings. Now as you can see, we've got two large boilers over here, and they are piped in parallel. And what that means is that both boilers can operate at the same time or individually. So one could be isolated and cut off and opened up for maintenance, while the other boiler here continues to run and provide heating to the building. And this is the most common type of configuration for modern heating systems. The other version would be series, and for this type of building that's not really practical. So these boilers are the heat source for the heating system, and that heat is then pushed into the hot water of the heating system. And one of the terms you'll come across in these sorts of systems is the terms primary and secondary circuits. So, and as you can see here, we've got the primary pump set. So these two pumps here, primary pumps, they will push the water around the system. So they'll push this around the primary side. So that hot water leaves the boiler, enters into this pipework here, is sucked by the pump and then pushed out into this, the low loss header, which we'll have a look at shortly. And that water can then either exit through these pumps here up into the risers, or some of it will continue through into the other side of the header. So this is just one continuous pipe, and that will then leave that water and return back to the boiler at a lower temperature to pick up more heat and continue that cycle again. I'll just show you an example of a low loss header. So we've got the boiler feed water coming into here, and this is the header here, common header, and so that hot water is entering into here, and that can either leave through this pipe or through this pipe, or it can continue down and back around into the boilers to pick up more heat. Now that water that leaves through these pipes can return back through these ones, and then that water will then mix with the flow. So the water that's coming through from the boiler, some of it will be sent down to return round, and that will mix with this return water here. And that is known as the low loss header or the common header. And coming off of the header from the hot side is these, which are risers, and these go off and these make up the secondary circuits. So in this example we've got 4 secondary circuits, 1, 2, 3 and 4. Some of them have got this dual pump, and this one has got a single pump. It may not need a pump if it's close enough and the primary pumps are actually powerful enough, but in most cases you will have a pump on this in this configuration. So I'll just show you a secondary pump there. So we've got these Grundfos pumps, so these will work to move that water up to wherever it's needed. We'll have a look at that in a second as well. And these will usually work in duty and standby. Same as the primary pumps, they'll also work in duty and standby. And that just means that one of the pumps is on duty, so that's the working pump, and the second pump is waiting for its turn to work. Usually they won't both run at the same time. It is possible that they can. In some configurations that is needed. But then the pumps will cycle. So for 1 week it might be pump 1, and then for the next week it might be pump 2, which is the duty pump, and the other pump won't run during that time unless the duty pump receives a fault and it can no longer operate, and in that case then the standby pump will then operate and take over. So you get security built into the system in these configurations. The same with the boilers, this can work exactly the same, so both can run or individually or neither. So these secondary circuits, they will take the water from this low loss header and push that up to where it's needed, and you can see in this first loop it's going off and feeding some radiators off on the first floor, or the ground floor even, and that water is then returning down for this one to the other side of the low loss header. And then the secondary circuit, you can see that riser there rising up the height of the building, and that is supplying the hot water to all of the fan coil units. So up here we've got fan coil units, and the return is also coming back into a riser, and that returns back to that common low loss header. So you can see that there. So here we've got the riser coming up, and we've got the connection coming off and feeding into that fan coil unit, the FCU. That then gives up its heat, and then that water then returns cooler back to the return riser, where it makes its way along here through the floor and then back into the low loss header. The third secondary circuit, you can see that feeding up and going off and feeding into the AHUs connected over here. That water then, obviously, once it's cooler, returns back to the header, makes its way back to the low loss header to make its way back to the boiler and pick up more heat. I'll just show you an example here of the heating coil on an AHU. So here we've got the flow, the water coming in from that secondary system, entering into this heating coil, where it gives up its heat to the air, and that heated air then goes off and is provided off into the office space. And meanwhile, that heating water returns at a cooler temperature and heads back to the boiler. And the final circuit on the final secondary circuit is this one here. So this is going off and feeding into a calorifier. Now the calorifier is where the domestic hot water is produced. So this is the hot water that comes out of the taps. And there's a lot of chemicals that go into this primary heating system, or the LTHW system, low temperature hot water system, and you don't really want to drink that. So what happens is the hot water is fed from here into the calorifier, and it passes into a heat exchanger where it just transfers its heat into some fresh water which is held inside the tank. That fresh water is then heated up, and that is supplied to the kitchens and to the sinks, etc. Meanwhile, that cooler water is returned back to the low loss header, where it mixes in with this and heads back to the boiler. And I'll just show you an example there. So this is free calorifier configuration, and you can see here we've got the heat exchanger just on the side there. So that hot water is coming in, exchanging its heat with the clean water on the other side, and that then makes its way back to the boiler. Meanwhile, the fresh drinkable water is taken off and sent off around to the building. Now you can also notice here we've got the expansion vessel and the pressurization unit. Now the pressure in the system is going to change. For example, if this pump set here, if that was off and it turns on, then this primary pump set here is going to see a pressure decrease because this has opened up, and so there's flow there, right? So if these pumps then stopped working and they isolated this, then these pumps will see a pressure increase because there is less room for that water it's pushing to go, and so the friction inside is going to increase and the pressure will build up. The same as if when the water in this loop increases temperature or decreases in temperature, then it's going to change in density, and that's also going to affect the pressure as well. So this expansion vessel and the pressurization unit is plugged into that, usually into somewhere around the low loss header. There's a couple of places it could be, but it's usually located here, and that's just looking at the pressure there, and it's going to react to that. So if it gets too high, then obviously the expansion vessel will take some of that, and when it gets too low, then the pressurization unit will force that back into the system to equalize it. And the pressurization unit will probably look something like this, where you've got the expansion tanks, the vessels over here, and then the main pressurization unit just there as well.